Hi, in this video we're going to talk about exponential equations. So the explicit form of an exponential equation is y is equal to some number a times some number b raised to the x, where a is my initial value and b would be my rate of change, is what you can think about it. In terms of recursive function, you can think of it as the next value is equal to the previous value, or the now value, times some rate. And I'm starting at some value of a. So the important to note between recursive and explicit forms, a recursive function pretty much tells us the step by step by step by step, and so I need that previous term and a starting term in order to continue and find the next term. Whereas explicit form can help me predict terms way out into the future. As long as I have an initial value and then a rate, I can figure out the 100th term. Whereas with recursive, we'd have to go through 99 different iterations to find that. So there are some disadvantages and advantages of using both. What we're going to look at is the explicit form of an exponential equation. So it's also important to note that depending on whatever your rate is going to tell you whether I'm growing exponentially or decaying exponentially. So am I gaining value, appreciating, or am I losing value or depreciating? So if your rate, or the b, is greater than 1, then I am increasing. So it's important to know that a lot of time rates are going to be in percentages. In percentages, for instance, a rate of 80% could be simplified as a decimal as 0.8. Because if you think about what percent actually stands for, percent, cent being 100, per 100. So this is 80 per 100. So 80 per 100, and per tells us division, so 80 of 100, which simplifies to 0.8. So that's where that decimal is coming from. You can also take your decimal place and move it to the left 2 times, but that's why you can do that. So it's important to know that if I'm growing, if I say my rate's 0.8 and I'm just going to multiply by 0.8, I'm not actually appreciating any. So I have to add a growth constant by saying 1 plus the rate. Likewise with decay, and decay is whenever my rate is less than 1, or if I'm using a percentage and I'm losing a percent each year or each day or whatever, I would use 1 minus the rate, because what that tells us is I'm losing at a rate of 80%. I'm losing at 80%, but it's 20% of the original value. So I'm multiplying by 20% to that original value, which is why I would use the 1 minus the r. So just some quick examples. If I deposit $100 in the bank with an interest rate of 3%, I would write an equation that looks like this. First off, we first need to define some variables. So if I said that x was equal to the time, and it doesn't tell us an interest rate if it's annual or if it's daily. So x would just be the time passed, and y would be the total amount in the account. So the total amount in the account is equivalent to how much I start with, my initial, so the $100 I first deposit, and then my rate of 3%. And now if I'm putting it into a bank, I'm going to appreciate value, so I'm saying a growth of 3%. I have to add that growth constant raised to an x, which can also be simplified to 100 times 1.03 raised to the x. And again, I can use this exponential equation as a function and input values to find an output. So if I wanted to find in 10 years how much is in the account, I would input 10 in for x and get an output of y. The next one, eagles are endangered. There are 40 eagles left and the population is reduced 20% each year. So again, I start with an initial value, which is 40 eagles. If I'm reducing 20% each year, that's a decay. 1 minus the rate, and I'm going to write that rate as a decimal, raised to the x. And again, this can be simplified. So notice this shows us that decay, even though I'm decaying by 20%, that's telling me that each year I'm at 80% of that value from the previous year. And so then again, I can use what I know about functions and input different times or years to get an output. And so it's extremely helpful to be able to set up these exponential equations so that you can predict things in the future, for instance, bank accounts, mortgage payments, etc. And so this is really the foundation of taking some value and increasing it by a specific rate. Okay, and we're going to use this. We use this throughout the course. Thanks for watching.